How's everybody doing? Welcome to day 2 of Corona Online Learning. First off, I just wanted to say I thought day 1 went really well. You guys worked really hard. There was good collaboration. Everybody seemed to participate in the quiz, so keep up the good work. And with that in mind, I think we should be able to stay on track and be able to do this as long as we can, providing we'll eventually get back onto campus. So the goal for today is to finish off chapter 4, which is the end of unit 2 here. So least common multiples and greatest common divisors, which we talked a little bit in section 4.1. So I kind of already went over this a little bit with you. So the first examples we're going to do is actually the same kind that we did in 4.1, which was using the set theory approach to finding these. And then the second example I'm going to show is how you can do it using the prime power representation. So let's first take a look at 1a here. So first thing we want to do is list the first 10 positive multiples of 8. So again, we just want to go through all the multiples. So we'll get 8, 16, 24, 32, 40, 48, 56, 64, 72, and then finally 80. And so now do the same thing for 12s. So we've got 12, 24, 36, 48, 60, 72, 84, 96, 108, and finally 120. And so again, what we're looking for are the intersections of these guys. So if we look, we've got 24s that appear on both lists, 48s that appear on both lists, and then 72, and technically we'd have more and more if we took the list further and further out. But again, since we're looking for the least common multiple, the smallest one that appears on both lists in this case would be 24. So in this case, the least common multiple of 8 and 12 would be 24. All right. So I'll leave 2 for you guys to practice. So again, use the same thing, write out the multiples, and then find what the smallest intersection. So now let's do a greatest common factor. So the first thing we need to do is list all the factors of 8. So in this case, we've got 1, 2, 4, and 8. And then same thing for 12. So we'll get 1, 2, 3, 4, 6, and 12. So in this case, so again, we're looking for things that are on both lists. So the things that are in both lists are going to be 2 and 4. But in this case, since we're looking for the biggest thing that's on both lists, the greatest common factor would just be 4 in this case. So the greatest common factor between 8 and 12 would just be 4. All right, so again, 4 is just like 2. I'm going to leave that guy for you. So that's our set theory approach to finding least common multiple and greatest common factor. So now, what if we wanted to find the least common multiple and the greatest common factor using prime power representation? So I'm going to do the same example, 8 and 12, so we know what the answer should be, so we'll check and make sure it works. So the first thing it wants us to do is write each of these in their prime power form. So again, if you forget how to do that, that's where you would do the factor tree. So in this case, like 8 is the same thing as 2 times 4. 4 is the same thing as 2 times 2. So in this case, 8 can be written as 2 cubed. And then if we do the same thing for 12, so 12 would be 2 times 6. 6 would be 2 times 3. So in this case, 12 would be written as 2 squared times 3 to the first. All right. So when we're trying to find the least common multiple, so remember, least common multiple is always going to give us a bigger number. Greatest common factor is always going to give us a smaller number.
Caleb, come here.
So what we want to do is first, when you're doing the least common multiple, you want to list every single prime power that exists. So in this case, there's only 2. We've got 2 and then we've got 3. And if notice at the moment I'm not putting any exponents down or anything. So when you're choosing the exponents, you want to choose the biggest exponent that occurs for each of the different powers. So for 2, I've got a squared and a cubed, so the cubed is bigger, so I'm going to raise this to the cubed, or third. And the 3, there's only one of them anyway, so we're just going to get 3, or 1 is our exponent. So now multiplying these two guys together, 2 to the third is 8 times 3 gives us 24, which if you remember, matches what we found above, so that's good. So for the greatest common factor, it's slightly different. So in this case, we only list the primes that they have in common. So in this case, 8 only has 2, 12 has 2 and 3, so the only one they have in common is just the power 2. And so in this case, instead of picking the biggest exponent, we always pick the smallest exponent that occurs. So again, we're ignoring the 3 because they don't have 3 in common. So in this case, I've got a 2 squared and a 2 cubed, so I want to pick the exponent 2. So in this case, 2 squared gives me a 4. So my greatest common factor would be a 4. And so again, if we look back up here, that's what we found using our set list as well. So the rest of them I'll kind of leave to you. So there's 2 on the front that you can practice using, least common or the set theory model, and then 6, 7, 8, and 9 is letting you use the prime power representation. So again, if you want to use the set theory model as a way to check it, feel free. So I'm also going to have a little quiz on 6, 7, 8, and 9 where you'll submit your answers so that way we can check them to make sure they all look good. So if you have any questions or anything like that, just let me know, and I will see you guys on Thursday. So good luck.